I was playing soccer with my friends. When the ball rolled down the road, that's when I noticed it was looking at us. It was up on the hill. It was standing there watching.
Hi, and welcome back to the last video about the reverse power rule. In the previous two videos, we looked at some of the more basic examples regarding the reverse power rule, and in this video, we're going to look at the most complicated examples. So let's take a look at our first one. It's going to be, if we want to take the antiderivative of, let's say, 3 minus x squared dx. And if you look at this, all of the integrand is trapped in this, being brought to the squared power. So if we want to take the antiderivative of this, we're going to first need to rewrite this as by actually multiplying this out, 3 minus x squared times 3 minus x squared, before we take the antiderivative. That's 9 minus 6x squared plus x to the fourth dx. At this point, we'll follow the rules from the previous video and expand this into 3 separate integrals. We'll take the antiderivative of 9 dx with respect to x minus 6 times the antiderivative x squared dx. In the previous video, I showed you how to take this 6 outside, but here I already skipped that step and I just brought out the minus 6 plus x to the fourth dx. And at this step, we'll use the reverse power rule. 9 will just become 9x. All of these will get plus c, but since we only need one plus c, we'll just save it for the end. Then we'll have minus 6 times x cubed over 3, once again using the reverse power rule, plus x to the fifth over 5, and then we'll just have 1 plus c for this entire thing. Clean it up a little bit to get 9x minus 2x cubed plus x to the fifth over 5 plus c. For our next example, we'll take the antiderivative of the square root of x to the third power dx. And for this one, we're also going to need to rewrite it before we solve it. So we're going to rewrite this as an exponent instead of as a square root. The square root of x is the same as x to the 1/2 power. So that's really x to the 1/2. And then all of that to the third power dx, or we can simply write this as x to the 3/2 power with respect to x. That's because 1/2 to the third power, multiply the exponents together to get 3/2. Now we'll take the antiderivative using the reverse power rule to get x to the 5/2, that's 3/2 plus 1, over 3/2 plus 1 is 5/2, plus c. Do a final rewriting of this to get 2/5 x to the 5/2 power plus c. Let's look at one more. This one, we want the antiderivative of this thing with respect to x. And if you look at the integrand, it looks really confusing, and you might be thinking, there's no way I can take the antiderivative of this. But for all these problems, and why these are the most complicated ones, is they all require just rewriting the integrand before you can actually take the antiderivative. So in this one, you have to realize what this means is negative x squared divided by x to the fourth and x divided by x to the fourth. They're both getting divided by x to the fourth, so we can rewrite this as negative x squared over x to the fourth plus x over x to the fourth, and that's with respect to x. Then, since we have two things being added together, we'll use the sum rule and split these apart to do negative x squared over x to the fourth dx plus x over x to the fourth dx. We can clean these up a bit by simplifying these fractions, so we'll have negative 1 over x squared dx plus 1 over x cubed dx. Once again, we still need to rewrite this a little bit more because we don't really like dealing with fractions. We want everything to look like x to the n. Because if it's x to the n, we get to use the reverse power rule. So let's write this as negative x to the negative second power dx plus x to the negative third power dx. If we want, we can bring this negative sign out front and multiply it in later, but as long as we remember to do that, we don't actually need to go through that step. We can do negative, okay, x to the negative 2 plus 1, so that's negative 1 over negative 1, plus x to the negative 3 plus 1, so x to the negative 2 over negative 2, and then plus c, because there might have been some constant that we've forgotten about. We're not actually going to take the antiderivative, but let's just look at a couple more examples from the con that you might run across, like x cubed plus 2x squared minus 4 over x squared. And how would you simplify this so you could actually take the antiderivative? Well, you just separate it into 3 separate fractions, just like the example I just did, dx. And then you'll simplify from here. Or maybe you'll get this one. It'll say, take the antiderivative of 3x times 6 minus x squared dx. And for this one, yeah, you're just going to multiply it out to get 18x minus 3x cubed dx, and then take the antiderivative once you've simplified it out a bit.